Welcome to D. Smith Science. I'm Derek Smith. Today we're going to be talking about why understanding the scientific method, scientific principles, why understanding mathematics and statistics are so important nowadays and today. So the main reason is so you don't get coaxed, so you don't get subject to misinformation, aka fake news. So there's a lot of information out there in this world. We have to cipher through what is relevant, what is erroneous, what is not correct, because there's a lot of information out there. I'm going to be using a classic example. So I'm going to be using people that believe that the world is flat versus the majority of people, I would say, that believe the earth is round. And so I'm doing this to show you how you can use statistics to create data that the earth is flat. And I'm going to debunk the Bishop experiment, and we're going to be talking about that. So why is that important? You're like, I know the earth is round. So this impacts you because people are using fake news, misinformation to promote discrimination and anti-science. So there's flawed methodology, aka flaws in their procedure on how they gather their data in published and unpublished studies to promote their agenda, what they want. And we're going to see that directly in the Bishop experiment. So statistics are manipulated to create a false narrative, to promote their agenda, what they want to get. When I worked in neuroscience, there was a term I've heard used, thrown around, was massaging the data, which basically means, I don't like that data set, let's do this again and let's throw those out. That happens in science. It happens in published peer-reviewed journals. So you have to be very strategic on how you get this information. So we're going to use this chart on how to spot false news, how to spot information. There is a myriad, there's a ton of these resources out there on the internet. I just grabbed one, and the link is below as well. And so we're going to look through these, and I'm going to talk about those briefly. So what I did is I Googled Flat Earth Society. There are two major organizations. They're being highlighted right now. So I chose the Flat Earth Society, and basically I'm showing you the click path on how I got to this information, and we're going to be debunking the Bishop experiment. So all of this information is taken from the Flat Earth Society. And so so we're going to the Bishop experiment. So what I'm going to do now, I read through the article, okay? And then I found this fact here. It says breaking down the Bishop experiment. What is boxed in red right now? That is the issue I found. I go, where did they come up with this number? After 1 mile, after you travel 1 mile, the earth should go down 8 inches, base of the curvature of the earth. So I was like, how do they get that? Well, then just the first thing I did, guys, was I looked at this chart, shown in this chart. I looked at that arrow, and that was written in 1881. So obviously, if you go back to that misinformation, how do you spot that false news? Check the date. They're getting their main source of information. The basis on this is 1881. Now you could stop there and say, well, the earth's not flat, because I don't, right? I delved a little bit deeper into it. So what I actually did, and if you looked at the text isn't very long, right? So suppose the earth has a sphere with a radius of 3,963 miles. So first off, I stopped right there. I was like, well, where did they get that number from? Where did they get that? So I did a quick Google search, radius of the earth, miles, and I got 3 to 4 top hits, all saying the same information. So, okay, that data point seems valid to me. Okay, so I like, well, that was okay. So then I go back to, okay, so if you're on point P on the Earth's surface and move tangent to the surface of a distance of 1 mile, then you can form a right triangle as in the diagram. The diagram in the website was not good, not helpful, and as a science teacher, I couldn't really follow it that well. So I just made my own. And this is what it kind of looks like. So a tangent, if you didn't know, is where a line intersects a circle or a curve at one point. So that point P, that red arrow, what it's pointing to, where the right angle is, that is the spot on the earth that this document is referencing. And they said, if you move a mile down, so the second dot, the bigger dot that's off of the circle, that is the 1 mile. So the distance from point P to the second dot is a mile. And so going back into this, they're going to use the Pythagorean theorem, and they didn't label it correctly, but that's okay. The mathematics actually on this is correct. So, but the logic is flawed. So what they're showing you here is that the Earth radius is shown in red, that's A, and then B is 1 mile, and obviously that's not the scale, right? And so if we use the Pythagorean theorem, a squared plus b squared equals c squared, if you plug those numbers in and we solve for c, okay, if we solve that number, we are going to get 3963.000016. So the major fallacy in this thing, in this document, is that they assume that the Earth is a perfect sphere. We know it's not a perfect sphere, okay? So if I subtract, the reason I subtracted these two numbers is due to, I just want to know how far the person's off the Earth, right? This is what they're saying. So I know from the whole point, the whole distance is that large number is C, all the way from the dot to where the human is, right there, right? So if I subtract C from that distance, from the total distance, I can get how far that person is supposedly above Earth. 0.00126. Once again, the problem with this is that Mount Everest is different than the Dead Sea in elevation. And so the major assumption with this is that the Earth doesn't have any hills or mountains, which we know, especially living in Colorado, is not true. So if I do dimensional analysis, I change miles to inches, I get 7.98, which is what the document talks about. That is their basis on this, 8 inches. And so if I go back to that chart written in 1881, this is where this information came from. This is being cited in a website that's showing up now. And the major fallacy, so the mathematics in it is correct. There's nothing wrong with the mathematics in it. However, the major fallacy in this is that the Earth is not a perfect sphere. It's that one little detail totally changes all the statistics, guys. So, and this is how much I had to dive into this to find that major error. Think about if it's stuff that you're not 100% familiar with, how easily one could manipulate statistics. And that is why it's so vital and so important to understand mathematics, science, and the scientific method. More and more, don't trust any news source, poke holes in it, but it takes time to do that. Or find a source that you trust and make sure they're on the up and up, right? Make sure they don't have any biases. Hope this helped, and thank you for watching. Subscribe if you want.
Go, hit it.
Oh no, are you serious?
No way.
Are you serious?